In previous video, we studied division algorithm for polynomials. In this video, let us go into and study about the remainder theorem and factorization theorem. Remainder theorem. Remainder theorem means suppose a polynomial p of x is given to be divided by a polynomial g of x is equal to x minus a. Okay. If you observe this polynomial g of x is equal to x minus a, it is a linear polynomial, is it not, in the form of x minus a. Now the degree of polynomial g of x is 1. Okay. We can divide the polynomial p of x if its degree is greater than or equal to g of x, as we studied in previous video. So here degree of g of x is 1. So degree of p of x should be greater than or equal to 1. Then only we can do division of p of x with a linear polynomial. Okay. Now as it is a linear polynomial, we can get the value of x, is it not? So x minus a equal to 0, we will get x is equal to a. Is it not? X minus a equal to 0. We will get the value of x is equal to a. By division algorithm, for polynomials, we have p of x is equal to g of x into q of x plus r of x, is it not, which we studied in previous video. In place of g of x, here we have to divide with a linear polynomial of the form x minus a. So write down here x minus a, g of x is x minus a into q of x plus r of x. Okay. If x is equal to a, that is in place of x we have to replace with a, that is polynomial p of x becomes p of a is equal to x minus a becomes a minus a into q of a plus r of a, is it not? This becomes 0, a minus a is nothing but 0 plus r of a. Okay. In the given polynomial g of x is equal to x minus a means a is a real number, where a is real number. As a is a real number, remainder r of a will also become a number. A number means nothing but it is a constant, is it not? A number is nothing but a constant. So let us take it as a r. Okay. So whenever you finally the remainder theorem states that whenever a polynomial p of x is divided with a linear polynomial x minus a, where a is a real number, we will get remainder as p of a. Remainder will be r is equal to p of a. This is remainder theorem states. Okay. Now let us take an example and using the remainder theorem, let us find the remainder. Suppose the example is given as p of x is equal to x cube plus 3x square plus 3x plus 1 and g of x is equal to x minus 1 by 2. Here it is a linear polynomial, g of x is a linear polynomial and you have to check with the degree of the polynomial, it is 3, is it not? So it is 1, it is 3. So degree of p of x is greater than degree of g of x. So we can do division for these two polynomials. It is clear. Now as it is a linear polynomial, we can get the value of x, is it not? X minus 1 by 2 equal to 0. You will get x is equal to 1 by 2. Okay. Now by remainder theorem, we learned that the remainder will be P of A. P of A, here A is nothing but 1 by 2. So, P of 1 by 2 equal to 1 by 2 whole cube plus 3 into 1 by 2 whole square plus 3 into 1 by 2 plus 1. Okay. This is equal to 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. Okay. LCM will be 8, is it not? So, this will be 1 plus 6 plus 12 plus 8. This is equal to 1 plus 6 plus 12 plus 8 is equal to 27 by 8. Therefore, remainder will be 27 by 8. Okay. We find the remainder without doing division, simply substituting the value of x in P of x by using remainder theorem. If they give any linear polynomial and a polynomial P of x, and if they ask to find the remainder, simply substitute the value of x there, you will get the remainder. Now let us go into factorization theorem. Factor theorem. Okay. This factor theorem, the name itself, it is clear that you are going to find the factors for a polynomial. Okay, without doing the division. Suppose they given a polynomial, to divide a polynomial P of x by g of x is equal to x minus a, where a is any real number. Here degree of the polynomial is 1, it is linear polynomial, and so the polynomial P of x will be, degree of polynomial P of x will be greater than or equal to 1. Only if this condition satisfies, we can divide a polynomial P of x with the g of x. It is clear. So, by remainder theorem, when we are ready to divide a polynomial P of x, we have remainder theorem in our hand to find the remainder, is it not? By remainder theorem, we have if this g of x divides P of x, then the remainder will be P of a. Okay. Now, by division algorithm, we have P of x is equal to g of x into q of x plus r of x, is it not? Here g of x is x minus a into q of x, and we have remainder as, when this g of x divides the P of x, by remainder theorem we have the remainder as P of a. Okay. So, we have P of x is equal to x minus a into q of x plus P of a. Now, if P of a is equal to 0, okay, if this becomes 0, then you will get P of x is equal to x minus a into q of x. Is it not? This becomes 0, then you will get x minus a into q of x. So it is clear that p of x, the polynomial p of x can be expressed as a product of a linear polynomial x minus a and a polynomial q of x. So when it is expressed as a product of linear and a polynomial means this is a factor of p of x. Is it not? Then only we can express these two as a product. So clearly x minus a is a factor of p of x. Okay. If p of a, if this remainder becomes 0, then x minus a becomes a factor of p of x. This is one statement of factor theorem. Now let us study the second one. P of x divided by g of x equal to x minus a means x minus a is a factor of p of x. It is clear, right? So if x minus a is a factor of p of x, then p of x can be expressed as x minus a into g of x, is it not? It can be product of x minus a into x minus a. We doesn't know what will be the p of x. So it can be a product of x minus a into g of x. Is it not? Now if x minus a is a factor of p of x means we can get the value of x, is it not? By equating it to 0. So you will get x is equal to a. Substitute this value here. You will get p of a equal to a minus a into g of x. So this is equal to 0. So we got p of a is equal to 0. So if x minus a is a factor of p of x means p of a is equal to 0. This is the second statement of factor theorem. So in factor theorem you have two statements. If p of a is equal to 0, then x minus a is a factor of p of x. If x minus a is a factor of p of x, p of a is equal to 0. This is the factor theorem. Now let us take an example and study about the factor theorem. Example, suppose p of x is given as p of x is equal to 2x cube plus x square minus 2x minus 1, g of x is equal to x plus 1. And if they ask us to verify g of x is a factor of p of x. If this is the problem given, we studied in factor theorem that if this is the factor of p of x means the value of p of the value after substituting the value of x here, this should be 0. Is it not? That is the factor theorem states x minus a is a factor of p of x, p of a is equal to 0. So as it is a linear polynomial, we can get the value of x plus 1 equal to 0. You will get x is equal to minus 1. Now substitute the value of minus 1 in p of 1. By factor theorem, p of minus 1 equal to 2 into minus 1 whole cube plus minus 1 whole square minus 2 of minus 1 minus 1. This is equal to minus 2 plus 1 plus 2 minus 1. You will get 0. So p of minus 1 is equal to 0. Therefore x plus 1 is a factor of p of x by factor theorem. By this we have studied completing factor theorem as well as remainder theorem with examples. Hope you have understood. Please like, share and subscribe for more videos on more concepts. Thank you.